At the end of this lesson, the student will be able to define resistance, resistivity, current density, and conductivity. Describe the drift of electrons. Define the mobility of charges. State the limitation of Ohm's law. Ohm's law states that the current passing through a conductor between 2 points is directly proportional to the potential difference. The constant of proportionality, R, is called the resistance of the conductor. All conductors possess resistance to some degree. Resistance of a conductor depends on its material and dimensions. The SI unit of resistance is ohm. Let us consider a conductor with cross-sectional area A and length L. The resistance of a conductor is directly proportional to its length, that is, R proportional to L. The resistance is also inversely proportional to the cross-sectional area of the conductor, that is, R proportional to 1 by A. Combining these two equations, we get R proportional to L by A, and we can write R is equal to rho into L by A, where rho is the proportionality constant and it is called as resistivity of the material. Resistivity depends on the material of the conductor but not on its dimensions. It is a physical property of a material. The SI unit of resistivity is ohms meter. The chart gives the values of resistivity for different types of materials. Conductors have low resistivity and insulators have high resistivity. Electrical conductivity of a material is the capacity of the material to conduct an electric current, where sigma is equal to 1 by rho is called the conductivity. The unit of conductivity is mho per meter. Current per unit area flowing through a conductor is called current density and is denoted by J. So, J is equal to I by A, where A is the area perpendicular to the current. Unlike current, current density is a vector. The SI unit of current density is amperes per meter squared. When there is no applied electric field, the electrons in a conductor will be moving randomly inside the conductor. The average current in any direction will be zero. When an electric field is applied, the electrostatic force will accelerate electrons. Because of this force, the electrons drift in the direction opposite to the electric field and current flows. Electrons tend to move in an irregular path due to collisions with atoms with an average velocity. This phenomenon is called drift and the velocity of electrons is called drift velocity. The electrons keep on colliding with atoms continuously. The average time between successive collisions of the electron is called relaxation time and it is denoted by tau. The average drift velocity of the electron in an electric field E is given by Vd is equal to minus E tau by Me, which is equal to minus E tau by M times V by L, where E and M are the charge and mass of the electron respectively and L is the length of the conductor. Drift velocity is written in vector form as Vd is equal to mu E, where mu is called the mobility of electrons. Consider a conductor of cross-sectional area A having n free electrons per unit volume. Each electron has a charge minus E and move at velocity Vd. The total charge moving past a given point is del Q is equal to n minus E Vd del T A. The current through the conductor is given by I is equal to del Q by del T is equal to minus Ne Vda. As Vd is equal to minus E tau by M, so I is equal to minus Ne times minus E tau by M into A, we get I is equal to n e square tau Ea divided by m. By definition, I is related to the magnitude J of the current density by I is equal to modulus of J times A. The vector J is parallel to E equal to Ne square by m times a conductor to which an electric potential is applied drift and collide with atoms of the conductor. The collision process. The electrons in a metal are very mobile. This is high mobility of electrons accounts for many properties of metals such as good conductivity. Mobility mu is defined as the magnitude of the drift velocity per unit electric field. Mu is equal to modulus of Vd by E. The SI unit of mobility is meter square by volt into second. As Vd is equal to E tau E by m, hence drift mobility mu is equal to Vd by E is equal to E tau by m, where tau is the average collision time for electrons. Mobility of electrons is reduced by collisions with atoms. Although Ohm's law has been found valid over a large class of materials, there do exist materials and devices used in electric circuits where the proportionality of V and I does not hold. The deviations broadly are one or more of the following types. V ceases to be proportional to I. The relation between V and I depends on the sign of V. The relation between V and I is not unique. That is, there is more than one value of V for the same current I. Materials and devices not obeying Ohm's law in the form of V is equal to Ri are actually widely used in electronic circuits.
This module consists